We're going to work through a moderately complex LSMW example, mass update of SAP Retail Article Master, using LSMW to create ArtMass IDocs. This isn't just a demonstration. I want you to understand the thought process that goes into creating a solution. So with that in mind, as we go step by step, I'll explain concepts and call out pitfalls. For your part, I assume you already have a basic understanding of Article Master and have at least seen an IDoc. In about 40 minutes, you're going to be an LSMW expert. So let's explain the mass update scenario that you'll work through. We're going to mass update 3 fields in Article Master: purchasing group on the basic data view, article description, and our requirement is limited to English only, and purchasing group on the logistics DC view, the value of which can be different than that of the basic data view and can also be different by site number. Sounds simple, right? Well, maybe not. Updating multiple Article Master views requires you to consider one-to-many relationships from source to target. Well, what does that mean exactly? Consider a typical data flow from a data source through LSMW to an IDoc, and finally updating Article Master basic data in an SAP system. In the simple case, updating only basic data, one-to-one relationships exist from start to finish. There's only one source data file, only one source structure in LSMW, which maps to each used segment of the IDoc. But with multiple data levels in the target object, one-to-many relationships appear, perhaps across the board. These red flags point to the complexities of every data migration project. It's no surprise that the majority of our LSMW design time will be spent on this topic. It's your task to define the relationships correctly in LSMW. By correctly, I mean according to your objectives. If you were planning an end-to-end data migration and reconciliation, then you'd worry about relationships at every touch point. But to design the LSMW object, you focus more sharply. I'm going to say it again, you always begin with the end in mind. In this case, focus on the ArtMass IDoc. Consider your mass update requirements, then work your way back towards defining the source structures and the source data files. That's the proper sequence. Let's begin to do exactly that. T-code WE60 can be used to display the definition of an IDoc, but this table listing some of the ArtMass segments is a bit easier to read. Each IDoc segment is a target structure. The first step is to choose the IDoc segments required to support our mass update scenario. The IDoc segment names loosely incorporate Article Master table names. You can spot some of the necessary IDoc segments simply on that basis. The mathead segment is always required when using an ArtMass IDoc. The first segment for any IDoc is usually mandatory. Purchasing group on the basic data view is table MA1. Article Master incorporates the concept of X segments, which we'll discuss later in detail, but for now, notice that there's an X segment for MA1. You need that segment too. For article description, you need table MAKT. Interestingly, notice that there isn't a corresponding X segment for MAKT. And finally, purchasing group on the logistics DC view is table MARC. MARC also has an X segment. Filtering on the chosen IDoc segments, you see that only 6 are relevant for our example project. So now let's think about relationships. Remember, each IDoc segment is a target structure. So would 6 source structures, 6 source data files, be the right number for your project? Probably not. Each source structure, each source data file, represents the possibility of a one-to-many relationship. You have 6 segments, but certainly not 6 relationships. The question is, how do you decide on the correct number of source structures? I always begin by listing the key fields for each IDoc segment. Grouping IDoc segments by key fields is the proper way to begin, because you know this is how SAP defines relationships between the target structures. The key fields represent the SAP data model. With this understanding, work backwards towards the source structures. The first possibility to consider is one source structure for each group of key fields. This aligns the source structures with the SAP data model. With this grouping, you see there's a separate source structure for the article description segment. That provides the possibility for article descriptions in multiple languages. A one-to-many relationship exists based on language key, which is standard and that's not surprising. You should ask, do I have a mass update required for multiple languages? Can this be simplified? If the update requirement is limited to English only, and it is, then article description is a one-to-one relationship with basic data. A separate source structure isn't required for article description, and you can logically group those IDocs segments together. The result is one less source structure, one less source data file. With this grouping, like the previous grouping, you see a one-to-many relationship for site data based on site number. You should ask, do I have a mass update requirement for more than one site number? Can this be simplified? If the requirement were limited to one site number, say a reference site or a particular DC, then the site data would also be one-to-one with basic data. A separate source structure wouldn't be required for site-level data, and you could logically group those IDocs segments together. The result would be a single source structure, only one source data file. The point is, there isn't a one-size-fits-all answer to the question of how many source structures is correct. It could be 3, or 2, or 1. It depends entirely on your objectives. Defining fewer source structures is simpler. It requires less data preparation. Defining more source structures is flexible. It's more accommodating of change. For something quick or throwaway, I always prefer the least number of source structures that will satisfy requirements. But for data migration objects that will likely change over time, I usually prefer source structures to be aligned with the primary keys of target structures. Your mass update objective is English only and for multiple sites. To that end, you'll create an LSMW object with 2 source structures and structure relationships as shown here. We spent a lot of time talking about relationships at a high level, so let's recap quickly. The relationships between segments of an IDoc are fixed, but your requirements, which are not fixed, contribute to your decision for the number of source structures and their relationships to IDoc segments. But how are multiple source data files related to each other? That's field level detail, and we'll get to that. But for the moment, keep in mind that it's an open question. Now that we have a high-level plan, let's create an LSMW project. These are the LSMW process steps. You work through them in order to define the target object, source objects, and field mapping. You can't skip any of the highlighted define and map steps. Notice that the sequence of the steps demands that you begin with the end in mind. This is all about the IDoc. In this case, it's all about an art mass. So you'll begin there and work your way back towards the source data files. When that's done, when you have a completely defined LSMW project, then it's possible to repeatedly perform the read and execute steps using different source data files. If there's an error, for example, let's say a source data error, then after clearing the error, always return to the read data step and begin executing in sequence from that point. In this step, you'll define the LSMW project, subproject, and object. Start T-code LSMW and then make those entries. Put the cursor back in the project field and then click the Create button. Make the description entries when prompted. And then click Execute to launch the project. Select the process step and then click the Execute button. Each process step starts in display mode, so you always begin each step by switching to change mode. Select the object type of IDoc and then make the message type entries. When you're finished, click the Save button. LSMW alerts you that settings for IDoc inbound processing must be defined for this project. Let's go back and make those settings. From the initial LSMW screen, on the main menu, choose More, then Settings, then Inbound IDoc Processing. A file port won't be used by LSMW, but must be created as a prerequisite for inbound IDoc processing. Left-click the File folder, then click the Create button. Enter a file port name, in this example LSMW, and a description. Then make fictional entries for directory and outbound file name. It doesn't matter what you enter here, they won't be used, but the entries are mandatory. Click the Save button, then go back. Enter the file port name that you just created, LSMW. Enter a partner type US and a partner number, in this case, LSMW. Next, we'll create a user partner profile for the LSMW. Select partner type US and click the Create button. Enter a partner number, in this example LSMW, and the partner type. Use your own SAP user ID for the processor entries, then save the partner profile. Now we'll create an inbound parameter. We're going to use message type ArtMass and process code BOPI. Use trigger immediately for this example. We're not going to use background processing. Click the Save button and go back. If you import an LSMW project from a file, then you have to make these settings again. Finally, we're going to activate inbound IDoc processing. Then go back and resume executing the LSMW project. Next, you'll define two source structures as planned. Choose the radio button for this process step, and then click Execute. Each step begins by switching to change mode. Then click the Create button to create a source structure named Basic Data File. Click the Create button again and create a second source structure at a lower level. You'll name this one Site Data File. The two structures define a parent-child relationship, but based on what? Remember the open question, how are multiple source data files related to each other? It's still an open question. Click Save, and then go back. In this step, you'll define the source fields for each source structure. How do we begin? Repeat after me. You always begin with the end in mind. So you begin by looking at the target fields in each IDoc segment. You already have the high-level plan for mapping target structures, the IDoc segments, with the source structures, which are the source data files. Now you need to choose the relevant target fields from each IDoc segment. The source fields will consist of the unique list of target fields for each source data file. You only need to include the fields for which you'll supply source data. For this step, ignore the fields that will be set to fixed values, or any that you may set programmatically. This is the short list. These are the only target fields for which you'll supply source data. The short list of target fields per source data file becomes the list of source fields. The key fields for each source data file are marked to indicate your expectation of how the two source data files are related. File number 1 is the article master basic data, and we expect the data in file 1 to be sorted by primary key by material number. File number 2 is article master site level data. We expect the data in file 2 to be sorted by its primary key by material number and plant number. Finally, we expect a row in file 1 with a material number for every material number to be found in file 2. Now define the source fields. Choose the radio button for this process step and click Execute. Each step begins by switching to change mode. Left-click the basic data file and then create the first source field. Use field names to match the IDoc field names and field lengths to match the IDoc field lengths. Left-click the field you just created to select it, and then create the next field. Then left-click Site Data File and repeat the process for those source fields. When finished, verify the fields are in the correct order. Click the button named Fields with the Same Name. The fields with the same name in each source are highlighted. LSMW assumes that the source data files are related by the keys inferred from fields with the same name. As you can see, that's not valid. Only the material field links our two source files, not the combination of material and purchasing group. This is a potential pain point if you're not aware of the hard-coded assumption. So what should we do to fix this? In this case, simply rename the purchasing group field by adding an X at the end. Double-click the field to change it. Now the highlighted fields show the correct key fields. Article number is the only field that links the two source data files. Save and go back to complete this process step. Here's the plan for how source structures, which are the source data files, relate to the target structures, which are the IDoc segments. Now define the structure relations. Choose the radio button for this process step and click Execute. Each step begins by switching to the change mode. For each of the 6 IDoc segments that you'll use, left-click the segment, then click the Create Relationship button, and assign the appropriate source structure. When you're done, click the Save button and go back. In this step, you'll map values into all required target fields in all used segments. You can map the fields manually, but there's some functions to help with mapping, and we'll use those, for better and for worse. These are the target fields to be mapped. The source fields have the same name, but there's one exception. Purchasing Group in File 2 was renamed to Purchasing Group X. Let's get to it. Choose the radio button for this process step and click Execute. Each step begins by switching to change mode. Left-click the top-level node and then collapse the tree. Now you can easily see each of the target segments and can work through them one at a time. Because the field names in the IDoc mostly match the field names in the input structures, you can use auto field mapping as a starting point. Choose More, Extras, and Auto Field Mapping. Take note of the settings that we're using. This is a good start and a real time saver. A line of ABAP code is added for each matching field. For example, here we see that mathead material equals basic data file material. Even if you don't write ABAP, it's relatively easy to recognize and understand the action. Work through all of the segments and examine each target field that you plan to use. And pay attention to the fields that the system would like you to use, such as function. For example, left-click the function field to select it, and then add a rule. You want to supply a constant value, and the value we want is 005, but take note of the other available values. A line of ABAP code is added to supply the constant value for the field name function. Now let's add a constant value using the dedicated button for that purpose. Add a constant value of X to the Basic View and Logistics DC View fields. If you'd like to avoid including leading zeros in source data files, then left-click the field name for material and add a rule. We're going to choose Move with Leading Zeros. Notice that the rule inserts ABAP code to call a standard function module. We're going to use this rule for every segment where you map material. Keep working your way down the list of segments, mapping each relevant segment in turn. Notice the purchasing group in MA1 is already mapped by auto field mapping. After scrolling down, you reach the first X segment, the X segment for MA1. X segments must be populated with key field values and also with a value of X for each field to be updated. Without a value of X in the X segment, the field won't be updated. There's a feature on the Extras menu. It's named Complete X Structures. Like auto field mapping, it's supposed to fill in all of the X segments, but don't use it. In the case of ArtMass IDoc, it will create dozens of incorrect entries, and you'll have to remove them one by one, manually. Instead, manually map fields in the X segments when using an ArtMass IDoc. So let's go attend to those. Maintain the constant value for the function field. The key field is material, and you know the rule for material. But look what auto field mapping did with the purchasing group field. It mapped a source field value. This is an X segment, and purchasing group is not a key field. The value we want here is an X, but perhaps only sometimes. You have to answer this design question. If you put a constant value of X here, then existing values will always be updated by the source data file. Existing values will be set to blank if no value is supplied in the source data. In a mass update scenario, a constant value of X is required here if you want to set existing data to blank values. But what if you only want an existing value to be updated if a value is supplied in the source data file? In other words, if a value is not supplied in the source data file, then existing values are not to be disturbed. There's a conditional rule for that. It's a rule named xField. ABAP code is added with the conditional rule. Only put a value of X if there is a value in the source data file. Watch as I map the material description segment. Can you anticipate the entries? And again for the MAR-C segment. Notice that plant was already mapped by auto field mapping, but purchasing group was not, because the field name was changed in the source file to purchasing group X. You'll have to map that manually. After selecting the purchasing group field, click the source field button and choose the source field. Now comes the X segment for MAR-C. You should be able to anticipate these settings based on our previous discussion for X segments. Click the Save button, and then go back to complete this process step. In this step, you'll specify the source data files. Choose the radio button for this process step and click Execute. Each step begins by switching to change mode. The system proposes file names for the imported and converted data. You'll create entries for the source data files located on the PC. Source data files haven't been created yet, but enter the expected full path and file name for the basic data file. And then also a description. Choose Delimiter of Tabulator for tab delimited and set the options for field names in order. Then repeat the process for the article site data file. Click Save and go back to complete this process step. In this step, you'll assign the source data files to source structures. Choose the radio button for this step and click Execute. Each step begins by switching to change mode. Left-click each source structure and assign its source file. Then click Save and go back to complete this process step. Congratulations, you've completed the design and creation steps for this LSMW object. Now it's time to create two source data files. You'll use these to unit test the LSMW object. Excel works great for this task, so create a new Excel workbook. It's a good habit to format all cells in your worksheet as text. Otherwise, if your data has leading zeros, then Excel will drop them. Our example data doesn't include leading zeros, but a habit is a habit, and you should start practicing it today. Maintain the data, making sure that field names are in the first row, and fields are in the same order that you specified in Define Source Fields process step. And then save the files as text tab delimited. Use the same file name that you specified in the Specify Files process step. I like to check the result with Notepad++. With the Show All Characters feature, you can easily confirm proper formatting. You can see the properly formatted data, with tabs between each field and carriage return line feeds at the end of each line. If LSMW reads your data improperly, this is a good place to look. The format of the data may be incorrect. Now repeat those steps for the second source data file. In this step, you'll read data from the source data files. The initial screen can be used to select transactions from the source data. Leave these empty and all source data will be used. Click Execute and the data is read. When the data was read, it was transferred from the source data files on your local PC to a file on the SAP application server. Note the number of transactions read and written. That's the number of article master records, which is the same as the number of IDocs that will result. Note the number of records read and written. That's the number of rows written into the source structures. Go back and back again to complete this process step. In this optional step, you'll display data that was read into source structures. You can select a limited number of lines to display or click Continue to display all lines. The data is displayed in the format of the source structures. Clicking any line displays the data line with corresponding field names, enabling you to more easily confirm that the data was read properly. Go back and back again to complete this process step. In this step, you'll convert data from the format of source structures to the format of target structures. The initial screen can be used to select transactions from the source structures. Leave these empty to convert all transactions. Click Execute and the data is converted. When the data was converted, it was read in the format of the source structures in the read file and written in the format of the target structures to the converted file on the SAP application server. The conversion occurred as a result of the ABAP code that was created or maintained during the defined field mapping process step. Note the number of transactions read and written. That's the number of article master records, which is the same as the number of IDocs that will result. Note the number of records read and written. That's the number of rows read from the source and written into the target structures. Click back and back again to complete this process step. In this optional step, you'll display data that was written into target structures. You can limit the number of lines to display or click Continue to display all lines. The converted data is displayed in the format of the target structures, which are IDoc segments. Click any IDoc segment to display the segment with corresponding field names. This makes it easy to see the result of the field mapping process step, the result of processed ABAP code. Go back and back again to complete this process step. In this step, you'll create the IDocs using converted data. Click Execute and the converted data file is processed on the SAP application server. In this step, you'll process the IDocs created in the previous step. This is the execution of the mass update. Click Execute and click Execute again to process. This message is unexpected, but it happens sometimes when only one or a few IDocs are processed. Normally, the list of processed IDocs would be displayed. That's no problem. Just start T-code WE02 to see the IDoc monitor. The last two IDocs are our successfully processed IDocs. Let's have a look at one and see the contents of each segment. Now let's have a look at one of the updated Article Master records. That concludes the successful unit test of our LSMW object. Thanks for watching. Now go and use what you've learned to create your own mass updates via LSMW and IDocs.